So lesson 7.1, I'm going to introduce you to periodic functions. And so the objectives of this lesson, I want you to understand the characteristics, behaviors, graphs of periodic functions. So you just looked at a particular scenario involving the classic Ferris wheel. They said that the Ferris wheel has a diameter of 60 meters and completes one full revolution every 4 minutes. And the center axle of the Ferris wheel is 40 meters above the ground. And so I asked you some questions about a passenger's height on the Ferris wheel. So let's take a look at our Ferris wheel here. So they said that the diameter of the Ferris wheel is 60 meters. Right. So what that means is that the radius of our Ferris wheel would be half that, so 30. So that means from the center of our Ferris wheel to any point on the circle, that would be a radius of 30. So this height right here from the lowest point to the axle would be 30. They said the center axle of the Ferris wheel was 40 meters from the ground. So if you were to go from the center to the ground, this is 40 meters. So what that means is when the passenger actually gets onto the Ferris wheel, the passenger is already 10 meters off the ground. At its highest point, remember the distance from the center axle to the ground is 40, and then the radius is 30. So at its highest point, the passenger is 40 plus 30 meters above the ground, so 70 meters above the ground. And they reached that highest point. They said one full revolution every 4 minutes. So if that's halfway around, so they get on, they go on, so halfway around would be the 2-minute mark. So at the 2-minute mark, they've reached their highest, their like maximum height of 70 meters. So where are they at the 1-minute mark? Well, at the 1-minute mark, they'd be right around here. And so they're going to be a total of 40 meters off the ground at the 1-minute mark. Then they're 70 meters off the ground at the 2-minute mark. And then at the 3-minute mark, they'd be back at being 40 meters off the ground. And then at the 4-minute mark, back at 10. And so I can take all this information and I can sketch it and get a graph. So when the passenger first gets onto the Ferris wheel, they already have a height of 10 meters off the ground. After that 1-minute mark, they're here at a height of 40 meters off the ground. That 2-minute mark, they've reached their maximum height, 70 meters off the ground. At that 3-minute mark, they're back to being 40 meters off the ground. And at that 4-minute mark, they're back at their lowest point, 10 meters off the ground, and then it repeats. And so let's just say it goes around twice. So this is what the graph of a passenger's height with respect to time would be on the Ferris wheel. So this is a periodic function, and a periodic function is a function that repeats itself in regular intervals. We call these intervals cycles, and the length of each cycle is called a period. So take a look at these graphs of periodic versus non-periodic functions. I just want you to see what I mean when I say they repeat exactly in regular intervals. So on page 1 in your notes, you have some like formal definitions of periodic functions, as well as some of those characteristics that I mentioned. So a function is called periodic if its output values repeat at regular intervals. The period is the horizontal distance that it takes for the graph to complete one cycle. The midline is the horizontal line between the function's maximum and minimum output values. And the amplitude is the vertical distance between the function's maximum value and the midline. So let's see what period, midline, and amplitude look like in our Ferris wheel function. So amplitude is the vertical distance between the function's maximum value and the midline. So if we're going to identify amplitude, it'd be helpful to identify the midline, which is just that horizontal line midway between the max and mins. So if we look at this function here, my midline is at 40. Sorry. I just can't win, you guys. Sorry about that. I'm trying really hard here. But here's my midline. It's at 40. It's in between the maximum and minimum values because I have a minimum value on this graph of 10 and a maximum value on this graph at 70. So the midway point would be at 40. So I would say that the midline of my function, and since it's a line, I want to give it the proper equation. So I'd write y equals 40 because it's a horizontal line. Now my amplitude, they said up above, is the vertical distance between the function's maximum value and the midline. So if I were to look at the vertical distance between the maximum value and the midline, I'm going from 70 to 40, and that's 30. So I have an amplitude of 30. And then what is the period of the Ferris wheel function? Well, they kind of gave this to us in the original problem. They said that one full revolution is every 4 minutes. But I can also see it in the graph because this is what one cycle of my Ferris wheel function looks like, and then it starts to repeat itself. Okay, so the period would actually be 4 minutes. So I have another visual for you guys here. So here I have a graph of a periodic function, and it's showing you that the amplitude is 2, the midline, they didn't write the equation, but it would be y equals 3, and then the period is 4. So the amplitude is that vertical distance between the maximum value and the midline. There is a way of calculating amplitude if you're struggling with seeing what the amplitude is. And that's what this formula over here is. So the capital M is the maximum value and the lowercase m is the minimum value. So in this problem, I have a maximum value of 5 and I have a minimum value of 1. So I can calculate amplitude by going maximum minus minimum and dividing by 2. So that'd be 4 divided by 2, which is 2, and that's what they got for their amplitude. So if you're struggling with seeing what the amplitude is, you can always calculate it. The midline is the horizontal line between maximum and minimum values. Once again, if you're struggling with seeing where the midline is, you can calculate it, and this is the formula for calculating max plus min divided by 2. So I can go 5 plus 1 divided by 2. 5 plus 1 is 6, divided by 2 is 3, and that is my midline. The period. So when you go to identify the period of the function, you really want to identify what is one cycle. So you could highlight what one cycle is. Where you start on your graph doesn't really matter. Maybe you want to start always on the y-axis when you go to identify cycles. Maybe since my midline's in there, maybe I wanted to start there and I want to be like, okay, here is one cycle of my graph, and then it starts to repeat itself. Whatever you got to do in order to see what the period of your function is. But if I go with my highlighted piece, I started at 1 and then I ended at 5. So 1 to 5, that's 4 units long. That's my period. So definitely look for a cycle that's being repeated. And that's going to help you in identifying the period of your function. Okay. So why don't you guys take a look at problems 2 through 5 on page 2 in your notes packet and see if you can analyze these properly. So is the function periodic? And if you say yes, it is periodic, then I want you to also identify the period, the midline, and the amplitude. So take a few minutes and do these 4 problems and then check back in with me.